Hey students and family members, it's Mr. Panza. Today, at the Me Time Station, we'll be learning about how you can determine if a number is either prime or composite. The definition between the two is quite simple, but it can be confused. A prime number is a number that has only two factors. An example would be 5, because the only two numbers that can be factors of 5 are 1 and the number 5. No other two numbers, when multiplied together, will get you the exact whole number of the product 5. Numbers that are only divisible by 1 in itself, meaning when you divide 5 by 1, you're only going to get 5, but that's it. The only other number you can divide 5 by to get an exact whole number is 5. So if you check for divisibility with any other number, you're always going to get a remainder, or not an exact whole number, because it will have a remainder. The first 6 prime numbers are 2, 3, 5, 7, 11, and lucky 13. 1, as you noticed, was neither. It's not prime or composite. What is a composite number? It's the opposite of a prime number. This is a number that has more than 2 factors, or at least 3 factors. An example would be 6, because yes, 1 and 6 are factors of that number. When multiplied together, you get 6, but 2 and 3 are also factors of that number. More than 2 numbers will get you the product of 6. Numbers that are divisible by 3 numbers or more than 3 numbers are composite numbers. In school, we've been practicing with the teacher doing it. We've been checking for divisibility after we've listed the first 6 prime numbers, 2, 3, 5, 7, 11, and lucky 13, to try and find primes between, say, 14 and 20. What I told students to do is list these numbers out, put them into charts, and then follow these steps off to the right. These steps tell us to create factor rainbows. Factor rainbows will show us if a number is prime or composite. We started to then practice together. We took a look at the numbers between 31 and 40, listed them, and then checked for divisibility by creating factor rainbows. Now the bigger question comes, how do you know if a number is prime after you create a factor rainbow? Let's take a look at some examples. If I were trying to find the prime numbers between 56 and 65, first I'd list them out, and then I'd test them by creating factor rainbows. And you can see that 56 is a composite number. That's because there are more than just 2 factors. More than just 1 and 56 are factors of 56, because when you multiply 2 times 28, you get 56. When you multiply 4 times 14, you get 56. And when you multiply 7 times 8, you also get 56. This is a composite number because it has more than 1 rainbow linker. If, however, you get 1 rainbow link and that's it, we call it a LAMO rainbow or a prime number. What I'd like you to do is be able to spot the prime numbers between the numbers 56 and 65. So we've got to check them out. First, let's try 57. Try it out like I have here and tell me, is 57 a prime or composite number? When I continue to factorize number 57 to see what numbers multiplied by each other would get me 57, I notice that 1 and 57 are 57, but also is at least 3 and 19, which means 57 is a composite number. Let's continue to check the other numbers. How about 58? Go ahead and do the prime factorization or create a factor rainbow starting with 1. And rainbow link to 58 to check and see if 58 is prime or composite now. And then answer the question, is 58 a prime or composite number? 58 is not a LAMO rainbow. That's because 1, 2, 29, and 58 are all factors of 58. And if you have more than 2 exact factors, then you know that 58 is a composite number. Let's check 59. Is 59 a prime or composite number? Create the factor rainbow on your chart now and answer the question on the video. Because the only number that can produce 59 is 1 and 59, meaning the only 2 numbers that are factors of 59 are 1 and 59. This is a prime number. Prime numbers create rainbows that look like this. I can also check because if I take 59 and I divide it by 2, I do not get an exact whole number, meaning I'm left with a remainder. If I take 59 and I divide it by 3, I do not get an exact whole number. The same can be said when I check for the divisibility of 4, 5, 6, 7, 8, and 9. You're going to be left with a remainder, which means 59 is a prime number. It's the first prime number between the numbers we were looking at. Let's check the next one, 60. Is 60 a prime or composite? Create the chart on your workspace now and answer the question. Is 60 prime or composite? 60 is also a composite number. It is not a lame-o rainbow. I checked for the divisibility of 2, 3, and 4 and recognized they all match an exact whole number. When I checked 4 on my calculator, you can see that 4 connects with 15. You can also see that 5 is also a factor of 60. When you take 60 and you divide it by 5, you get an exact whole number of 12. And anytime you get an exact whole number, you've created another rainbow link. Let's check the other ones at this point. At this point, you can check 6 to see is 6. It is, because 10 would be the number that matches up. And then I could check 7. How do I check 7? Take 60, divide it by 7, and recognize that it is not a factor. 60 divided by 8, not a factor, and 60 divided by 9, not a factor, which means these are all of the factors of 60. And because there's so many rainbow links, it makes it a composite number. How about 61? Go ahead and run through the process and tell me now on the computer screen, is 61 a prime or composite number? 61 is a prime number. That's because when I checked for the divisibility of all of these numbers, I received a remainder, which means they were not divisible by, they were not whole numbers, exact whole numbers. The only time I got an exact whole number is when I divided 61 by 1, and that can be said for every single number because of the identity property of multiplication. Let's move on to the final 4. Is 62 a prime or composite number? Go ahead and run through the process and give me your answer now. 62 is a composite number. It has more than 2 factors. Let's check 63. Is 63 a prime or composite number? Check it now and place your answer. 63 is a composite number. There are many factors of 63. Even though it's odd, that doesn't make it a prime number. 64, is it prime or is it composite? You can see that with all of these factors, a non-lame-o rainbow, 64 is a composite number. Last one, is 65 prime or composite? Run through the steps and answer now. Only 4 total factors, 1, 5, 13, and 65, but it's a composite number because it's not a lame-o rainbow. 61 is a lame-o rainbow, and 59 is a lame-o rainbow. So if we go back to our original question, then the answers would be the prime numbers between 56 and 65 are 59 and 61. Every other number is a composite number. And why? Because composite numbers have at least 3 factors. All of these had at least 3 factors except for 59 and 61. And that's how you determine if a number is prime or composite. You need to know the definition of prime or composite and how to create factor rainbows. Hope you did well on the questions.